Hello, everyone. You are welcome once again to the lesson on vectors. Okay, in today's lesson, we are going to start with the solution to the assignment that was given in our previous lesson. That was lesson 2. Okay, so here, if you look at the question critically, you realize that you've been given position vectors. So it means, okay, though you are told that the position vectors are of A, B, and C. When you are extracting, you extract them as such. As for the extraction, I think everyone, okay, had it right. So it will be your position vector of A is OA, which has a special notation A. B, OB, which has the special notation what B. Tilde, don't forget your tildes. Then C, OC, which will give us, okay, exactly what you have here. I thought as much. The light is out. Let me, okay, connect my table net to the power bank, then get back. So like I was saying, you extract the vectors in the corresponding special notation, or if you like, you can use the OA, OB vector, OC vector. It's allowed. Okay, however, remember I told you anytime you read question, underline the salient part. So I'm assuming this was underlined. Show that the triangle ABC is right angled at B. So it means anytime, please take notes. Okay, this was what was missing in some of your presentation. In maths, anytime you read any question, okay, and then let me say, especially geometry question, and you see a particular figure mentioned, make sure you draw the figure in your solution. It's very, very important. So usually maths will be given for that sketch. Okay, but here, you know, you cannot draw lines with your free hand, so you use the appropriate instruments. Okay, so we are told that it will be right at B. So this is where my 90 degrees, so I can draw it at aside because I know that once the question said show, I know that I will end up getting a right angle. So I will indicate my right angle, it will be at B. Once you fix B, the two other points, you can fix them anywhere. So your A could be here, your C could be here. Okay, only that I decided to put my A here and my C here. Very critical. Very soon you get a particular information. Okay. Now, for you come and state your condition, your premise for your argument. Under what condition can you say that a triangle will be right at B? And we know that for triangle ABC to be right angled at B, okay, the vector BA, okay, dot the vector BC should be equal to 0. Okay, some of you did the wrong thing. I marked you right. Okay, but please take note. Remember, you were told yesterday that if you want to use the dot product and for the dot product to be valid, your vectors must be directed towards a common point or away, okay, from a common point. So in this case, if you want to dot the vectors to get the angle, okay, here to 90, therefore the dot giving you 0, okay, make sure you indicate your arrows. So I am looking at what? My vectors moving away from that common point B. So it means if I'm dotting, I need to dot BA and BC. BA and BC. If you come and dot A, B, and BC, and you end up drawing the same conclusion, please, okay, it is just one, okay, in a situation that you will get this, okay, to be valid. Usually it will not. So this question was just to expose how you would dot the vectors. So if you come and write AB dot BC is equal to 0, you ended up getting 0, okay, and therefore you had the right conclusion drawn. Immediately you write that, and you don't dot where your vectors are moving towards a common point or away from a common point. Straight away, you've started wrongly, so we know you will land wrongly. So those of you who did that, okay, I pardon you because maybe that was the first example. Next time, you will not be pardoned. Take note of that. Am I clear? Hello, am I clear? Because when
Yes,
you are
please.
dotting, it's either you, if you want to use AB, okay, then you can see the immediately you use AB, the arrow is moving towards your vectors B. So you have to use dot CB so that the arrow will also move towards. So in that case, you'll be looking at your vectors moving towards, okay, that common what angle at B, or that common point B. Okay, so take note of that. Very critical whenever you are dotting vectors. Okay, so here unfortunately you don't know BA, but you know how to find BA. BA will be A tilde minus B tilde. So you go and perform your algebra, you substitute your A, your B, you end up getting this to be your BA vector. Then in the same way, your BC vector will be, okay, the position vector of the point was C here, the terminal point minus the position vector of the initial point. Okay, then you go and substitute and you perform your algebra. This gives you this. So at this point, I can say that this implies that my BA.BC, which I wanted to find, but because I didn't know BA, BC vectors, I had to go through that to find them. Now that I know, I can dot. And whenever you are dotting, remember we said it will be the X, okay, component of each of the vectors that you are dotting, multiplying. So it will be the X component here is 1. So it will be 1 times -1. Sorry, -8, forgive me. Then plus the Y component also multiplying. So -4 times -2. So that's exactly what you have there. And this gives us -8 plus what? 8. So that gives you 0. So you draw the conclusion that therefore triangle ABC is right angled at B as required. Very, very important. Please take notes. Okay, this is supposed to be your ideal presentation and therefore the ideal solution. Am I clear? Any question? Is there anything that I underlined? Is there any question mark that I indicated that you think you are still not able to relate? Okay, get why I did that. Okay, so at this point, I will assume all concerns are addressed. All major concerns are addressed. Okay, so on that note, okay, we are going to look at how best we can make use of all that we've learned so far, okay, to solve likely exams questions or maybe past questions. So let's look at our next set of questions. Okay, and very interesting, pay attention. Sometimes, okay, you will be deficient in a way, okay, because there are certain information that, okay, I have not given you, but as we solve the questions, I will make those, okay, information known to you. So let's go to our first, okay, question. Okay, the point R has position vector. Okay, so, okay, this is the point R with its position vector. Okay, then RS with this QR, find the position vectors of P, the points, okay, S and Q. So this is how best we are supposed to deal with this question. Okay, so solution, that's what you write first. Questions are numbered because we usually want you to number your solution. So you number as well, then you extract. So given, and please don't go and write capital R because we said R is the position vector of this. So you use R tilde. Is that clear? Is my point well made? So it's R tilde that is equal to, okay, -3, okay, 2. Okay, then you go and extract your R vector RS. Okay, that one is direct. So that will give you -2, -1. And your last vector, which is vector QR, okay, to be equal to 5, okay, 2. All right, so now you've extracted. We are asked to find the position vector of the points S and what R. Sorry, S and Q. So it means you need to find S tilde, small s tilde, or OS vector, or Q tilde, okay, or OQ what tilde. Sorry, OQ vector. So I will use because of how we've started here, we will use the small letters, the special notation for the position vectors. However, this is what you do. You can find, okay, S from, okay, the vector RS. Okay, so what do we do at this point? You come and write, okay, but your vector RS, you know, is equal to your vector S tilde minus the vector R tilde. Is that clear? Is my point well made, my professors? Are you following?
Yes, please.
Okay, so your S minus what? R. Okay, so this implies that you know RS, you are told is -2, -1. Okay, oops. Okay, then this should be equal to S, you don't know. That's what you are looking for. Minus R, and you know your R. Your R is what? -3, what? 2. All correct. So you basically make
Yes,
X,
please.
go and make S a subject. So that means you have to move this one to the side. So in my mind, I'm moving this one to the side, but I'll still write my S first. So S tilde is equal to, then I will move this one. So that will give me -2, -1, then plus, okay, 3, -3, okay, 2. All correct. So in effect, I can say that therefore my S, okay, so that will be equal to this plus this will give us -5. Okay, this plus this will give us +1. So I found my S. I need to go and find that of what's the Q. So, okay, and if I want to find the Q, I have to use this, okay, vector. So, and you know that the vector QR, okay, you know, will be equal to R tilde minus what? Q, okay, tilde. Okay, so this implies that you know QR, that is what? 5, okay, 2. Should be equal to your R tilde, okay, minus what? Your Q tilde. And your Q tilde, sorry, R tilde we know, forgive me. So we have to go and substitute, okay, that straight away. You know R tilde. Okay, so sorry for that. So after that, we know that is what? Okay, -3. Okay, so -3, then 2, +2. That is your, then minus what? Your Q tilde. That's what you are looking for. So in this case, you bring the Q tilde here. So I'll get Q tilde to be equal to, okay, -3, 2. Then you bring this one to the side, which will give us minus, okay, 5, what? 2. Okay, so in effect, we are going to get, therefore, your Q tilde will be equal to -3 minus 5. So that will give us -8. Then 2 minus 2, and that will give us 0. Okay, so this will be 8 in terms of. And remember, I've told you, the form that your vectors will come, okay, should inform you that any vector that you are asked to find must also be in that form, unless otherwise stated. Is my point well made?
Yes, please.
Okay, so on that note, okay, you are in the best of positions to do this. Okay, so you should be able to do this one. It's very similar. Okay, point A has coordinates. Okay, only that here you write giving A 3, -2. However, you know you'll be working with vectors. So after extracting everything, you come and write. This implies that A tilde is equal to, then you take it to what? The vector form. So any point that is given, take it to its vector form. Here you were not told that what you have here is what? The position vector. So you are told that what you have here are coordinates of this point. So you extract it as a point, not as what? A vector. Is my point well made? So you use this one
Yes,
to
please.
find, okay, the coordinates of x. And so with this one, take note, you were asked to find the coordinates of x, y, and z. Okay, so it means you need to conclude in the point form, in the row form, not in the column form. So you will get the vector. Okay, let me do one for you. Okay, so that maybe you use that one as a guide. So solution. Okay, so question 2. What are we giving? We are giving the point A, which is what? 3, -4. Okay, then we also have the AX vector to be equal to 4, 4. Okay, then we have AY vector, okay, to be equal to -2, -1. Okay, and your last vector, which is what? AZ vector is equal to -2, okay, 1. Okay, I think there should be something wrong. I should have edited this, I guess. Okay, other than that, okay, there will be, I did copy and paste. I'm very sure that these two vectors are not the same. However, let's work with them, assuming that's it. Other than that, it means these two vectors are equal. Okay, so however, let's assume this is the question and we'll work with that. I just want to make a certain, okay, fact. Okay, so now this is what we have. But because you'll be working with vectors, all point given must be taken to the corresponding vectors. All right, this implies that, okay, the point A will have this, the position vector OA, which is A tilde, and you write it in terms of column, and that will be 3, -4. Is my point well made? Okay, so at this point, you can go and write, but, okay, if I want to find x, I have to use this vector. A vector AX is equal to what? Okay, we know it will be your x, okay, tilde, minus what? Your A, okay, tilde. Okay, so this implies that you know AX, and that is what? 4, 4. Okay, this will be equal to, okay, x tilde, that is what you are looking for. So x tilde minus your A tilde, you know that one as well. So 3 minus 4. So in this case, you are going to get your x tilde, okay, that's the position vector of x, to be equal to, okay, to be 4, 4. Then you move this one to the side, which will give you plus, okay, 3, -4. So in effect, we are going to get this to be equal to, okay, 7, 0. Am I right? Okay, however, what you have here is the position vector of x. But the question didn't ask you to find the position vector. The question asks you to find the point x. And if you know, just as if you know a point, you know its vector, position vector. If you know the position vector, you know its corresponding point. So I'll write therefore, here my point x, I'll write it in the row form, will be 7, 0. Is that clear? Is my point well made?
Yes, please.
Okay, very good. So you do same to get your y and z. Be very careful. So here you are looking for the coordinates, so underline, not what the position vectors. Okay, so if that's the case, then we can move on to our next question. All right. Okay, so question number 3. Okay, as we move along, I will be asking you to tell me how best you will be dealing with certain questions. Okay, maybe I will even start from here. So here, okay, what do we do? Solution. That's what we write first. Okay, questions are numbered, so we have to number. Okay, then after that, we go and extract. So I'll ask for the extraction. Given, don't never add the dots. It's okay. So AB, vector AB to be equal to 4, 3 in the column form. Okay, and your vector AC. Is equal to what? Okay, 5, 12. Please take notes. Don't forget the arrows, especially when you use the points. Okay, so now at this point, what are we going to find? A. We need to find the magnitude of what? The vector AB. Okay, so maybe I will call one of you to help me deal with this. Let me see who will be on my radar. Okay. All right. Okay, Equia, Prof. Equia, let's go. How would you find the magnitude of vector AB? So tell me what you write, then I'll write.
The magnitude of vector AB is the square root of 4 squared plus 3 squared.
Very good. You are in a comfortable lead. As you come down, don't forget to write close to the margin. So let's go.
Yeah, square root of 16 plus 9. 925 is equals 5 units.
Very good. Okay, so all that I was expecting to hear, I have. So no, at this point, you could have drawn your conclusion, but because it is not drawn, you have to come and have it drawn here. Therefore, okay, the magnitude of what? Your vector AB, okay, is equal to, okay, 5 what? Units. All correct. Okay, all right, now let's look at that of the B. Okay, B, we are supposed to find, so you leave a line. Okay, never leave spaces between your steps. So unless you are moving from a sub question to another sub question, you know this. So AC vector, okay, will be equal to, sorry, the magnitude of that. Okay, so let me see whether maybe Janisha has been able to pick something from here. Prof. Janisha, let's go. Square roots, 5 squared, very good. Plus 12 squared. Okay, well done. So let's continue. Equal to, you come close to the margin. Root of 25 plus 5. Okay, so which will give us 169. Come again. 169. 169. Okay, which will be equal to 13. Okay, so at this point, I know I can draw my conclusion. Okay, so I'll draw my conclusion at that point because, okay, what I'll write will be my final answer. So I'll write therefore the magnitude of the vector AC, okay, will be equal to 13. Is that all? Janisha? Units. Units, very good. Okay, don't forget that if you cherish maths. Okay, so that will be it for A and B. Okay, in actual fact, it is the C. Okay, that is a little technical. So let's see. We are asked to find angle CAB. Angle CAB. And here, the figure is not mentioned. Okay, so you can choose not to, what do you call it, draw. But usually a sketch will be better, okay, for you to know. But I can give you a hint how you can deal with it when the figure is not mentioned, okay, and you don't necessarily have to draw for you to get your angle. Anytime you, okay, so this is what I have. Let me draw. Okay, assuming I have this triangle. Oh, I'm going to continue here. So let me, okay, leave the space there. Okay, let me come and write it somewhere down here. Okay, so assuming okay, let me draw it here. I have my triangle, okay, ABC. You can position your points anyhow. Okay, we are finding angle CAB, so the angle here, the angle at A. I hope I'm right. Okay, so you know, in vectors, if you want to find angles, what do we use? What do we use in finding angles in vectors? Okay, as for finding angles in coordinate geometry, where you are dealing with lines, undirected line segments, you know, we use, okay, tan theta is equal to, okay, absolute value of M1 minus M2 over 1 plus M1, M2. You know that, how to find the acute angle. But here, that is not what we are going to, because we are dealing with vectors. Okay, I think somebody, okay, has the answer already. Okay, but the question is, how do we find the angle? Or what do we use? What technique, what concept can we use to find angles in vectors? Before we even come and find the size of the angle. Okay, we use the dot product. Okay, so that's what we are going to use. So in this case, okay, we know we are going to dot two vectors, but before you can get the right vectors to dot for you to get the angle, the valid angle, you know what I've told you. The vector should move towards the common point A, or they should move away from the common point. So usually this is my advice. Just stand at where your angle is, in this case A. So it will be the vector AB, AC. A, B, A, C. So the vectors that you are dotting, okay, they should all start with what? At the point where your angle is. So the point where your angle is A. So it will be A, B, dot AC. And in that case, it will be moving away. AB dot AC, moving away. So I will have a valid vector or valid vectors to what? To dots. Please take note. It's my point well made.
Yes, please.
Okay, so the figure is not mentioned. So here I'm good to go. So I can write, I'm looking at C. Okay, I will let my angle, okay, because I know I'll be using theta, angle, okay, CAB be equal to theta. Because in the dots, when you are finding angle, okay, remember, we need theta. So in this case, okay, but I know that, okay, my angle, the AB vector dot what? AC vector in terms of the dot product should give me, when I'm looking for angle, the vector A, the magnitude of vector AB, okay, then, okay, times the magnitude of vector AC. Okay, but that is not of course, okay, in actual fact, cos of angle CAB, but you said that is what theta. That's the angle between the two vectors. Is my point well made?
Yes, please.
Okay, all right. Okay, so I think Kobe has asked, okay, a question that indirectly I've addressed, but I will go back. Okay, so Kobe, you said, okay, you can see if you use AB, if you want to use AB, if you look at AB here, okay, AB is moving away. So it means the other vector that you dot with the AB here must also move away from this point, and that will only be the vector AC. Is that clear? If I use vector BA, okay, the vector BA is moving towards A. So the other one that I will dot must also move towards A for the dot product to be valid. So it means that will be dot vector CA. In that case, they will. So if you want to use BA, then you dot it with what? CA. If you want to use AB, then you have to dot it with what? AC. Is it clear now, Kobe? Because your, okay, the concept about dot product, okay, we said it will only be valid when your vectors are moving towards a common point or away from a common point. Remember what we did yesterday as part of the notes. Okay, the first node. So that's how come. And I told you that for you to get it, always look at where your angle is. So here my angle is at A. So it will be, your vectors will always be A, your other, okay, point. So it will be AB, then what? A, your other points, AC. So A, B, AC. All of them will start with A. A, B, AC, as simple as that. Okay, without getting confused. Other than that, you need to come and indicate your arrows, okay, and make sure that you've protected your marks. Is my point well made? Okay,
Yes,
we found the magnitude of AB. Okay, we found the magnitude of AC. So what is left is what? The dots. Then we can go and substitute. So in this case, I'm going to find that. Okay, so AB dot what? AC. You know, will be equal to, when we are dotting, what do? We are supposed to multiply the corresponding component, then we add. So it will be 4 times what? Times 5, which will give us, so let me write it, 4 times 5, then plus what? 3 times 12. Is my point well made?
Yes, please.
Okay, which in effect will give us 20 plus what? 36. Okay, which gives us what? 56. Am I right? So obviously the dot is giving us a positive number. So that gives us an idea of the size of what? The angle. The angle cannot be more than 90. It will be less than what? 90 degrees. Okay. So you can see that because you didn't, Prof. Kobe, because you didn't use the right vectors, your angle was wrong. So it's very, very important for you to consider that, okay, information that you were given for validity for the actual angle. vectors must move towards a common point or away. Take note of that. So at this point, I can say that this implies I know all my parameters. So this implies that, okay, my AB.AC is 56, and that is equal to the magnitude of AB, that is 5, okay, times the magnitude of AC, and that is what, 13, then cos of what, theta. Okay, so in this case, what do we get? We are going to get 56 is equal to, what would this give us? Hello, I'm waiting. What would that give you?
$65.
Okay, so we are going to get, okay, 65. Okay, and it will be cos, okay, theta. Okay, so at this point, you know, you are looking for theta. So you write it again and you divide. So I'm going to get 56 over 65. Okay, it's equal to 65 cos, okay, theta over 65. Okay, so in effect, I'm going to get, let me write as well. I'm going to get cos theta to be equal to, okay, 56 over what, 65. Okay, so theta will be equal to cos inverse of what? 56 over 65. Okay, so do that for me. So do that for me. Okay. So at this point, I will get my,
30.51.
okay, so I'll 1, 2, 3. Okay, so therefore, I introduce theta. So you know theta accept it with and theta is angle CAB. Okay, so therefore angle CAB is equal to, you said you had 30 points.
30.5102.
Okay, you know you have to take it to 4 dp. It's an angle, so don't forget your degrees. Then you indicate your approximation for dp. All correct. Is everybody fine? Is everyone fine? Daisy, Prof. Daisy, are you fine?
Yes, please.
Okay, so we are making use of what we've learned so far, and that's how, okay, questions will come. Okay, so we learned the concept in isolation, but now we are putting everything together to deal with questions. Okay, so an entirely new question. Okay, not totally new per se, but okay, I'm going to introduce you to another, okay, information that I think, okay, you don't have yet. Okay, so now this is the question. Okay, you've been given the vector AB. This time around, it's in the magnitude bearing form. BC, all the vectors here are in the magnitude bearing form. And what are we supposed to do? We are supposed to find, okay, the addition of vector AB and vector what? BC. We are going to add these two vectors. Unfortunately, unlike the column vectors and the Cartesian vectors, where we can easily add directly, magnitude bearing, okay, we cannot add directly. Though under certain situations, we can add, and I will tell you, okay, those were situations, okay, peculiar situation we can add. And we have one of the situations here. So we'll go through the normal routes, okay, then after that, I will tell you if you encounter the situation, you can do it mentally straight away, a special situation. So this is it. Because magnitude bearing vectors are not friendly vectors, you cannot add them directly. You cannot easily perform algebra on them. You change it to the ones that you can perform algebra on them. So you either change it to the Cartesian form or you change it to the column form. However, preferably, okay, the column form. But take note, because, okay, your vectors here are in the magnitude bearing form. Okay, if you sum, any vector that you are asked to find must also come in that same form. I've made this, okay, statement a lot of times, so please take note of that. So here, what do? You write solution. That's the first thing that you write. After that, now you normal your solution. So 4, you extract. So what are we giving? We've been given the vector AB. Okay, you extract. It's in the magnitude bearing form. Okay, so I'm not going to, because of time, I will write all of them, but you will write. I hope you get it, just to save time. Okay, so now A, what are we looking for? We are looking for the vector AB, okay, plus the vector what? BC. So this is what we are going to do. This will be equal to, take notes. You need to convert this to the column, okay, form. And this is how you easily, okay, connect magnitude bearing form to column, okay, or component what form. And this is all that you need to do. It comes with a formula, and the formula will be, let me state it here. It will always be the magnitude of the vector. So if, let's say, I have, okay, a vector AB, okay, in the magnitude bearing form. So the magnitude will be AB, okay, and the bearing will be theta. Usually, if you want to convert this one to column, it will be the magnitude of the vector, okay, cos of the angle, okay, then the magnitude of the vector, okay, sine of the angle. Okay, that will be the column form. Is my point well made? Any objections?
No, please.
Especially those who have done it. Okay, I taught, okay, the Common students, okay, and even the elective and some of you in school how to move from the magnitude bearing to the column. So you agree?
Mr. Akman, please, does the sign come before the cos or?
Oh, I'm asking you, okay. So tell me if what I have here is wrong, you can let me know. You should be able to say something.
I thought it was the magnitude for the first line, the magnitude sine theta, then magnitude cos theta.
Very good. If you use the cos and the sine, then you have to be attaching the appropriate signs. Please take notes. If you write the cos first and the sines, okay, then you have to attach the appropriate sign. But here, we are going to go by the one that the signs will be embedded in your results or in the formula. So it will always be sine cos. Sine cos. So it should, that's why I didn't write it here. So it should be, take note. So it should rather be my magnitude here, which is 5. Take note of that. Okay, then sine, okay, your bearing angle, and the bearing angle, please ignore the 0, so 60 degrees. Then it will be 5 cos, okay, 60 degrees. Is my point well made? That's it for only, okay, the AB, then plus, okay, so let's go and do the BC. BC, what is the magnitude of what the vector BC? My professors, are you following? So let me do the needful here, especially those of you who would want to write. Okay, so let me effect the change here. So it will always be the magnitude of the vector. Your S component, okay, will be the magnitude of the vector, then sine the bearing angle. So sine the bearing angle, then cos the bearing angle. Take note of that. Okay. Okay, all right. So this is it. Okay, Kobe wants me to go over, so let me go over. Okay, so here, remember I said, okay, you are supposed to extract. I said because of time, okay, I'm not going to write everything, but you extract. So you write AB, vector AB, and all that you have here up to, okay, vector QR in the magnitude bearing form. Then we are looking at A, which is the sum of what your vector AB and your vector BC. But before I can sum these two vectors, okay, you know, they are not in the friendly form. So I have to change it to the other two forms, any of them, because those two are the friendly forms. I can easily add them. So in this case, what do I do? Okay, I said preferably you change it to the column. So the column 1 will give us, okay, the magnitude of the vector, okay, the sine of what the bearing angle, and the magnitude of the vector cos of your bearing angle. So you know that the column 1, you have S component, Y component. So the S component will always be given by the magnitude of the vector, then sine its bearing. Then the Y component will be the magnitude of cos what's the bearing. So what we have here is only for the vector AB. That's the column form representation of the vector AB. Now we are going to look at the column form representation of the vector BC so that we can add. So in that case, that is going to give us, what is BC? BC is this, so it will give us the magnitude, which is 10. Okay, then sine the bearing. And I've told you the bearing angle, please take notes, don't write 060. Okay, it is what, 60 degrees. Okay, then 10 cos, okay, 60 degrees. Okay, Kobe, is the explanation okay now? And your understanding, is it better?
Yeah, it's better.
Okay,
Thank you.
all right, you are welcome. Okay, so now this will be equal to, as you move on, each step you introduce that with equal to. So you are going to use your calculator for this. Though these are special angles, you can use your head, but please, okay, your calculators can help. So let your calculator help. So do 5 cos, sorry, sine 60, give me the value, I'll write it here. I want to get you involved, that's why. So please, I'm waiting.
4.33.
Come again.
4.3301.
Are you sure they didn't give you a set?
It gave me a set.
Yes, so it's better you leave it in the exact form for now.
5 root 3 over 2.
Okay, so 5, okay, root 3 over 2. Then 5 cos 60 degrees.
5 over 2.
Okay, so 5 over 2. My professors, I hope you are following. Don't approximate for now. You later come in.
Yes, please.
Okay, so because if you approximate here, you are going to approximate here. The more you approximate, the more you move away from the actual answer. Okay, so we are going to reduce our number of approximations. Okay, number of times we approximate. Okay, so 10 sine 60.
5 root 3.
Okay, so 5, okay, root 3. Okay, because it will be root 3 on 2, which will cancel that. Okay, then, okay, 10 cos 60.
5.
Okay, so in effect, okay, this is what we are going to get as the sum. Okay, so I'm going to write the sum this way. So okay, we are going to get 5 root 3 over 2 plus what? 5 root 3. Okay, then this one will give you 5 over 2. That's your y component plus 5. Is that clear? Hello, is it clear? So at this point, okay, please, you can approximate. Sum this, then approximate. So in that case, you approximate once. You get the point? So do the S component here, 5 root of 3 on 2 plus 5 root of 3. Give me your answer in terms of decimal. So don't come and approximate individually. Okay, it will move your answer away from the actual value. Okay, so here we are approximating only once. The person who does that will approximate here. So done 2 approximations. So it's likely you will veer off the actual value. And so I'm waiting.
12.9904.
Come again.
12.9904.
9904.
4.
Okay. Then what about this one? Its approximation in terms of decimal.
7.5.
Okay, 7.5. Okay, you can see that this one you approximated. So the one that you approximated, come and let us know that you approximated to 4 dp. Any approximation indicates. Okay, this one we know is the exact value. You didn't approximate. Okay, however, okay, we have to be very careful. You cannot conclude in the column form. Take notes. You cannot conclude in the column form because the vectors came in the magnitude bearing form. So at this point, that's where you apply. Unfortunately, we haven't done the Colmart vectors. Okay, other than that, immediately we get here, I will tell you this is how you deal with it. So, or you use the CORMAT approach to deal with it. So maybe I will tell you the answers, then we move on. But here, because, okay, I'm assuming we have not done that. Okay, this is what you do. You should know how to, okay, find the magnitude of vectors in the column form, which we know. Okay, because we've done, okay, we did, okay, 1 or 2 previously from the previous examples. Then you should also know how to, okay, get the bearing, okay, of any vector in the column form. So that's what we are going to do here, okay, going forward, because we have to write the magnitude of this, okay, column vector, which will give you the magnitude of the sum, which is the resultant. And again, the bearing, okay, and so that we can write this one in the magnitude bearing form. So quickly, let's go and find the bearing. So in this case, I can say that this implies that, okay, or let me even write, but, okay, my AB vector plus my BC vector, okay, the magnitude of that will be equal to root of, let's go, that will give us 12.9904 squared. I hope you are following. It's not pretty, but we have to work with it. That's 7.5 squared. Okay, you know that in exams, you won't always get pretty situation. Okay, so let's go. This will be equal to, I'm waiting, root of, give me the first value results. Okay, whilst I'm waiting, let me clear the other side. Hello, my professors, are you there? Please, let's go. We shouldn't waste time on this. When it comes to calculator work, I don't expect us to waste time on it at all.
168.75.
Come again.
168.7505.
05. Okay, then plus
56.25.
56.25. Okay. So at this point, you know, we are almost, okay, done. So we are going to get root of, okay, let's sum. Okay, let me see. What do we get? Okay, so
225.0005.
Okay, so what is happening? Okay, 225.
0.0005.
Okay, 0, 2 zeros.
3.
Okay, 4 dp. Okay, all right. So then in this case, this gives us, okay, the root of that will give us 15 point something. Approximately 15. So I'm waiting. I want confirmation.
15.0000.
Okay, so in actual fact, you are going to get 15.0000. Okay, but you know, this is the same as what? 15. Okay. And please, can I end with what's the 15?
No.
Okay, what do I attach?
Kilometers.
Unit.
Kilometer. You know the units this time round. Please take notes. Okay, because the unit here is in km. Any, okay, distance or magnitude that you find should also have the same unit. So it will be km, kilometers. Is that clear?
Yes.
Okay, so now that will be it for the magnitude. We will need the bearing as well. And this is how we are going to find our bearing. For the bearing, okay, this is what you, so I'm going to write bearing. Okay, will be equal to, for the bearing, you need to draw. So come in, because bearing angles are measured from the true north. Okay, bearings will be one of the topics that we'll do under CORMAT. Okay, so we need to come and indicate our Cartesian. So this is what you have. The sketch is very vital. You indicate your Y, your X, okay, and also your true north. Bearing angles are measured relative to the true north. Okay, and Please, you cannot use your free hand. You are supposed to use a straight edge. Okay, so at this point, please take notes. Okay, come and consider your vector here. Okay, and the vector here, the movement on the x-axis is positive. The movement on the y-axis is also what? Positive. So we are going to make a movement of 12 point something units here. Okay, so that's where I am going to. So as, this is what I will have. Oops. Okay, so forgive me, my, okay, pen is not reacting. Okay, so yeah. Okay, so the distance here is 12 point what? 99, okay, 04, you indicate. And you move, okay, a distance of 7.5, okay, in the positive direction of y. So you go up. So this distance will be 7, okay, point what? 5. Okay, so in this case, you join this, and this now becomes your vector. Okay, the angle here will be theta. Let's call this angle because we will need it. Bearing will be the angle from here to the angle here. That will be our bearing. But we know that the size of the entire angle here is what? Is 90 degrees. So I can say that the bearing will be equal to 90 degrees minus the theta, which we can find. Is that clear? Oh, I should come again. Who wants me to come again?
Please come again.
Okay. All right. First of all, okay, get the, vectors basically are points, sort of. So immediately I express it in the column form, then it means I can indicate it on the Cartesian plane or in the Cartesian plane. Okay, so I have, assuming maybe you are given this point and you are asked to indicate, you know how to, this means you make a movement of this unit on the x-axis and a movement of this unit on the y-axis. But because this is positive, you make a movement of that unit on the positive y-axis, a movement of that unit on the positive what? Y-axis. X, positive, y, positive, you go up. If it was negative, it would have come down. In that case, our bearing will change. We'll do more, so definitely you'll get it. So we said immediately you started from here and you ended here. So when you join, you can see that you move from this point to this point. So your bearing, your direction will be this way. I'm talking about the vector because you started from here and you ended here. So it means you move from this point to this point. So this in actual fact is your vector AB plus what? BC, but I cannot write everything here. Okay. And we are saying that when you are looking at bearing angles are measured from the true north, okay, in the clockwise direction. Okay, unlike trig, we measure from the base x-axis, positive x-axis, then we measure anti-clockwise. But for bearing, we measure from the true north, okay, clockwise. So we are looking at the angle from the true north, between the true north and your vector. So that will be, okay, the true north is this line, your vector is this line. So you are looking at this angle. But we know the entire angle here. Is that not it? Because this, assuming this is beta plus theta should give us 90. You all agree? So if I know the size of this angle, I know the size here. I just subtract it from 90 and I'm good to go. So that's what I have here. So I'm going to find what's theta. And if you look at this, this is a right angle triangle. So obviously, okay, you've done trig. So once it's a right angle triangle, then you can make use of what? The trig ratios to find unknown angles as well as what? Unknown size. But I am interested in an unknown angle here. So I know the opposite and the adjacent of this angle. So which trig ratio should I use here? Obviously tan. So I will come and write, okay, but, okay, tan theta will be equal to opposite, which is 7.5 over the adjacent, which is what? 12.99, okay, 04. Is my point well made?
Yes, please.
Okay, so I know that theta will be equal to tan inverse of what you have here. And I always will tell my students not to approximate. Okay, use your calculator to do the whole of this so that you approximate once. Someone can do this, okay, division and approximate before coming to take. So your calculator, you can feed it with it and give you the exact value. So I'm waiting for theta.
29.9 99996.
9, 9. How many nines?
4.
4.
4
4
nines
9.
and a 6. So it's around
No, I'm talking about after the decimal point.
4.
4.
Yes, plus
Okay.
6.
Oh, then you know what to do. Okay, you
Yes.
shouldn't, okay, write this. So you approximate mentally before you write. Okay, so let me go and do the needful. So, okay, it will be 9999. So if you do that, we are going to get what?
30.
30. Okay, oops. Okay, so 30 degrees. All right, so you write 30 degrees. Okay, so in this case, I can say that, okay, this implies that my bearing, remember the theta is not your bearing, it's only a means to an end. So your bearing will be equal to 90 degrees, okay, minus what, 60 degrees, is that clear? Okay, and that will give us, so
30.
minus 30 degrees, forgive me. Okay, that will give us 60 degrees, but don't write 60 degrees, it's bearing. And bearing angles must be 3 digits. So you precede that with 0. So 060 degrees. Is that clear? But should I come again?
No, please.
Okay, so now we've not drawn our conclusion. So therefore, now the sum of the two vectors, the vector AB, okay, plus the vector BC, okay, will be equal to, you know, the magnitude. The magnitude gave us what? Okay, 15 km. Okay, comma, and the bearing gave us 060 degrees. I knew the answer before you started. Okay, and very soon you also know. This is the special situation where you can add, okay, vectors in their magnitude bearing form, get the answer straight away. Immediately you realize that you're adding two vectors in the magnitude bearing form. Your first point, of course, should be the bearing. If they have the same bearing, you thank God, you do sign of cross. Your work will be very easy. They are friendly vectors. The only vectors that will be friendly in terms of the magnitude bearing that you can directly add or even subtract will be the situation where, okay, your bearing angles are the same for the vectors. So in this case, okay, if I look at this, okay, the bearing angles are the same. So if I sum, they will also have the same bearing angle. But the distance, okay, from the sum will be the sum of the two distances here. And you can see that that was the situation. Should I come again? Hello, should I come again, or my point is well made?
Please come again.
Okay, I said, if you look at this, you can see that these two vectors that you were adding, they have the same, they share a common bearing. The bearing here is 60 degrees. The bearing here is also 60 degrees, 060 degrees. And whenever you have this situation where your vectors that you are adding, they are in the magnitude bearing form. Usually magnitude bearing form are not friendly, but we have a special situation, and that's what I'm walking you through. So immediately you have this, okay, without going through all this, you can get the answer. So in this case, I said, I will know that AB plus BC, okay, will give me the same bearing as this. So I know the bearing. But how do I get the distance? And the distance will be the sum of the two distances. So it will be 5 plus 10. That will give me 15. So I know straight away that this should have given me, or would give me, okay, 15 km, okay, comma, then was 0.6 degrees. In the same way, if I'm adding vector AB and vector PQ, can I add directly based on the information that you've been given?
No, please.
No, I can, because look at the bearing angle, 60 degrees, 60 degrees. I can add directly. Yeah,
Yes,
special situation. You get the point now.
yes, please.
So if I add AB and PQ vectors, my result will be, okay, I will come and sum the distances. So it will be 5 plus what, 7, which will give us what, 12. So I will get 12 km, comma, then the bearing angle will also be the same. the bearing of the resultant will be the same, which is 0, 6, 0. So if you go through this approach, that's where you will land anyway. But with this one, okay, this is not a special situation. The vector PQ plus the vector QR, they don't have the same magnitude. Sorry, the same bearing. So you cannot add their magnitude and keep the common bearing as your, okay, your result here. Is my point well made?
Yes, please.
Okay, so if we were supposed to do this, this would have given us vector PQ plus vector QR will be equal to vector PQ in terms of column will give us 7, okay, sine 60. Okay, then 7 cos 60 plus vector QR in terms of column will give us 15 sine 240, okay, degrees, then, okay, 16 cos 240. You come and deal with it the same way as we have here. All correct.
Yes, please.
Okay, very good. So indirectly now you know how to find, okay, the bearing of what vectors in the column form. Okay, we've done one. Okay, maybe we'll encounter another situation. Okay, so, okay, I would have done, okay, well, this cannot be 5. I think it's repeated. Or let me see if it's not repeated. Okay, it's repeated. So it should have been, oh, let me see. Yeah, it is. It is repeated. So it should have been 4 as well. Okay, it's not 5. Okay, repeated to do the B, to create space for the B. But I think I did the naming. Okay, so what we have here is supposed to be, okay, the same as the other one, and you use the space to do. Okay, so let's look at, okay, this particular situation. Okay, again, we are going to make use of the concept that we just, okay, learned. But the question is put in a different form directly. So let's see. Okay, a body is acted upon by forces, okay, P sub 1, P sub 2, okay, find the resultants. So we want to find the resultants, okay, then give the magnitude to 1 decimal place. So you remember as you read question, you underline the salient parts. Okay, so there is a required approximation, 1 decimal place, and that will be the magnitude. And the direction we need to take it to the nearest degree. We underline that there is a required approximation. The question is 2 in 1. First of all, we need to find the resultants. Then after that, okay, you need to find, even the resultant that you are finding, okay, you will need the magnitude as well as the direction. But here, the follow-up question here is just, it's not even a question. Okay, I mean, information that you have here is trying to tell you that in giving your resultants, the magnitude must be in 1 dp and the direction must be to the nearest degree. Is my point well made?
Yes, please.
Okay, so we start by our usual, okay, way. So solution, okay, one information that will be given here and that you will be good to go. Okay, question 6. Okay, so you extract, what are we giving? Okay, the forces, the name, so P sub 1 is equal to you extract, okay, 63 newtons, okay, 180 degrees. You know forces are vectors. Okay, so then you continue. You extract the other 2 as well. I've told you because of time, I'm not going to do that. And when we need it, they are here. I can pick it from there. So now you want to find the resultant. So that's all that you need to know. Resultant. Okay, let me call it R. Usually we call it R. I think science students, some of you will call it R sub F. Okay, what have you? But in math, R is okay for us. And the resultants will be, remember when we did the resultant, we said when we sum the vectors, then we get what's the resultants. So here, the vectors are forces, so we are going to sum the forces. So it will be the sum of force P1, okay, force P2, then force P3. All correct. Is my point well made, or I should come again?
Please come again.
Okay, so I said, okay, here the only information I'm giving is that anytime you are asked to find the resultant of, okay, forces, just sum the forces in play. That's all. The resultant will be the sum of all the forces in play. Is that clear? So my resultants are, Okay, I'm using R to denote resultant, will be equal to the sum of the forces, but the forces are P1, P2, P3. We are not done. No. Okay, this is just the first statement to guide you. So if you don't know that the resultant will be the sum of the three forces, then you cannot continue. So it means indirectly, we are going to have this to be equal to the P1, P2, P3, the forces are in the magnitude bearing form. You cannot add them directly. Okay, and take note, because the forces are in the magnitude bearing form, okay, the resultant must also be in that same form. But unfortunately, you cannot add the vectors in that because they are not special. If all the three forces are special, then the angles must be, the bearing must be the same. But unfortunately, no. So it means here we have to go our usual route. Okay, so we come and write this one as, okay, the column form of force one will be 63, okay, sine, or your bearing angle, which is 180 degrees. Okay, then 63 cos your bearing angle, which is what? 180 degrees. Don't forget the degrees when you write the cos and the sine. Then plus your P sub 2, this is it. So the column form of that will be 50, then sine the bearing angle, which is 40 degrees. Okay, then 50, okay, cos the bearing angle, which is 40 degrees. But that's not all. We are left with the third one, okay, which will give us 28, the magnitude, and sine the bearing angle, which is 150 degrees. Then 28 cos the bearing angle, which is what? 150 degrees as well. All correct.
Yes,
Is my
please.
point well made? Okay, so at this point, okay, so let's see. I just want to see whether I'm praying that we'll get, okay, a vector which will not be in the first quadrant, so that we'll know how to find the bearing, the direction. The direction is the same as the bearing anyway. So now, okay, help me with your calculator values.
0.
Okay, so and as you mature, you will know, okay, that this will be what? Will be 0. 180 will be on, okay, on the line. So your y components will be 0 here. Okay.
Negative 63.
Okay. Plus
32.1394.
38.3022.
Okay. Then last one. I'm waiting.
14.
Are you sure? 28 cos 150. 150 is not a special angle.
No, that's
A sine
okay. I said
150.
14. Yes, please. That one is 14.
Then 28 cos 150. Okay, this will give you that will to come and cancel. So cos 150 the same as, okay. Okay.
Minus 24.2487.
Please, do you all agree?
Yes, please.
Okay, and once you have approximated, okay, and you did all your approximation to 4dp, you indicate, okay, 4dp beside it. Okay, so now let's go. Okay, so sum, okay, 0, so sum these two. Okay, so that is going to give us, okay, 46, am I right, point? Okay, 1394. Is that clear? Okay, and come and sum, okay, minus 63, 38 point, this, sum this and give me the result here. In fact, a situation that I am looking for. Okay, it will not be in the first quadrant. So I will address another situation in terms of the bearing. Okay, hurry up for me, please. Hello, I'm waiting. Okay, we shouldn't waste time.
Minus 48.
Minus 48.
Yes, please.
Mhm.
Point 9462.
Okay, and here you didn't approximate because, okay, the maximum approximation is 4 dp. Okay, it will come in terms of that approximation. Okay, are we fine?
Mr. Please is 65 rather.
It's 65. It's not 62.
9. Yes, please.
Okay. All right. So let me clear it. Okay. So if you all agree, then we are good to go. So at this point, you know, we need the magnitude of the resultant. So in this case, I can write the magnitude of the resultant, which is R. I'll use R to represent the resultant. So R in that, okay, in the cell, the magnitude. So that will give us 46, okay, points. So in brackets, okay, 0.1394, okay, squared. Then, okay, plus in brackets minus 48.94, okay, 65, okay, squared. So I'm waiting. Root of. Let's first of all deal with the square first. Then later, if you want to use a calculator to do everything, you do so. Okay.
Please. 2 128.
2128.
Point 8442.
Plus I'm waiting.
Plus sorry, minus.
No, it cannot be minus. You are squaring the whole of this. Negative squared.
Sorry.
Oh, this one, someone should give us the value. Let's go.
2395.
2395.
95.759.
So 0.759.
7598.
Okay, I hope you did the right approximation. So at this point, use your calculator to give me the value straight away. Is Kobe here? Kobe, today you are not giving me the answers. Okay, in fact, you've stopped. You started.
Please, 454.
The root of, okay, the sum of this.
Yes, please.
Okay, 4.
524.604.
Please, I got a different answer.
That's not the answer.
No.
But in any case, how can you sum this? Okay, and the square root will come and give you this. Be careful, be careful. These are low-hanging maths that you are not supposed to get. Be careful before they beat you. Okay, so please give me, we've already squared and we are looking at what? Okay, the sum of this and this. Okay, I think it was rather the sum that you gave me.
Yes, please.
Not the square root. Okay, so please, okay, just give me your result. Let's go, let's go. Someone who is done, let me see if Kobe is in with the
67.2652.
Come again. 67.
0.2652.
0.2652. Okay. Take notes. Okay, so this will be newtons. Okay, and okay, here you can choose not to write even the newtons there. Your conclusion is what matters. And we are going to get what? 4 dp, and it will be in 4 dp. But the question, remember, in our approximation, when you are drawing our conclusion, we'll state it. Okay, the resultant will put it in this form. So that will be the form. So let's do that. So this will be equal to 1 dp because the resultant will ask to take it to 1 dp. 0.3. Is that clear? Newtons. And you put it in brackets 1 dp. Is that clear? Okay, so we are left with what? The bearing. The bearing. Okay, so now what do we do? In order to find the bearing, we need to what? Or the direction. Okay, we need to, so let me use direction here, or you can use bearing, no issues. Okay, bearing, we need to come and draw because we need to locate the quadrants. Okay, and that will help us get the angle. So here I have my y, I have my x. Don't forget to indicate your true north. Let me see whether, okay, he is in with the answer. Let's see whether we'll get the same result. So with this vector, you can see that the x component is positive. So it means you move that unit in the positive x-axis. That unit. So maybe here. And the unit, the movement is 46. Okay, 0.1394. My professors, are you following?
Yes,
Okay,
please.
and the movement, okay, here it is negative, so it means you have to move down because y is negative down, positive up, negative down. X is positive here, negative here, so you move down. Okay, but you move down how many units? 48, okay, 0.9465 units. Okay, and this is where you end. So you join this and that. So it means this will be the vector. You started from here and you ended here. So in actual fact, this will be your resultant, okay, vector. Okay, that's vector there, but
Mr.
this will always be 90. Yes, please.
Please, it's 46.1394.
46. Oh, not 48. Okay, thank you. So 46. How did I write the 48? Okay, so 46. Okay, then, okay, let me do the needful. Okay, quickly. So we are almost done with this question. Okay, so 46. So we are good to go. So at this point, okay, we need to find this angle, which you can always find. The angle between your vector and the x-axis. So theta. So in this case, your bearing will be the angle measured from the true north up to where your vector is. So from here to here. Okay, you should know. So it means that will give me 90 degrees. Okay, because I know from here to here is 90 then plus theta. Do you agree? Is my point well made? Oh, I should come again.
Please come in.
Okay, so as for where we have our vector, okay, in the quadrant, we should be, and please take note, let me quickly chip in this. Okay, you can see that it indicates negative here. You are dealing with the side of a triangle. The negative will tell you whether your movement, the quadrant, whether you need to move up, left, or right. Okay, so in this case, I don't write negative here because I'm dealing with the side of a triangle. It must be positive, it must be positive. Okay, so the movement, the negative is taken care of, okay, in terms of the positioning of what your vector. Okay, so take note of that. And we said the movement positive, movement negative, so you come down. So the negative has been taken care of by the movement down. So you just write, okay, the measure there, the distance there, the distance here too. So it means if this was negative, we would have moved in this direction, but I will write a positive value there. Okay, and the y was negative 2, then you move down. So negative, negative, you move here, then you move down. But here, once you move, always, okay, you are going to get a right angle formed. Okay, this line and this line, which will be a vertical line, will meet at an angle of 90. And between your vector and the x-axis of that quadrant, that's where your theta, your angle will be. So the bearing is the angle measured from the true north up to where you have your vector. So from here up to here, but you know that from here to here is 90. This is what I don't know, theta, and I can find theta. Okay, just like we found theta in the other one by using the appropriate trig ratio. So here, I will come and write tan theta. I know will be equal to opposite. So opposites will this time around be 48.9465. Okay, over the adjacent, and the adjacent is 46.1394. Oh, oops, 94. Okay, so in this case, theta will be equal to tan inverse of what you have there. Is that clear? So I'm waiting for your value. Forty what? 47 point something.
46 point
Okay, 46 points.
6910.
Okay. 46.6910.
10.
Don't forget the degrees, and you've approximated, so 4 dp. Am I right?
Yes,
Okay,
please.
however, we cannot end here because the question asks us to take it to the nearest degree. So the nearest degree will give us what? 47 degrees. Okay, nearest degree. Nearest degree. Is that clear? So now you come and draw your conclusion, therefore, your resultants, okay, will be equal to, you know, the magnitude. The magnitude in terms of 1 dp, and that is 67.3 newtons, comma, then your bearing, okay, will be 0.47 degrees. The bearing angle, oh, I haven't found the bearing, so I will remedy the situation here. Okay, you know, theta is not the bearing, so it will rather be 90 plus 47. Is that clear? So take note. The bearing, that's not the bearing. Okay, the bearing should rather be, okay, can I squeeze it there? Let me squeeze it there instead of erasing. You still get it. What is important is, okay, you understand. So now it means my bearing. This implies that my bearing will be equal to 90 degrees plus 47 degrees, which will give you 137 degrees. You always avoid writing, okay, more than, okay, 1 equal to on the same line. Okay, so that should have come down. Then in this case, this becomes, when you are drawing the, so it means this will rather be 137. Okay, degrees. Okay, so Kobe, you are right. Okay, so please, so you now know, so if your angle is here, assuming maybe your, okay, vector was here, you had negative, so it was here. In that case, your right angle will be here, your theta will be here. So your bearing will be the movement from here up to here. Okay, and in that case, you can say that because you know the entire movement here, this will give you 270 degrees, then minus theta. Okay, that will give you only the distance or the angle here. Is that clear? Take note. If your vector was located here, okay, in that case, your theta will be here. So your bearing angle from the true north will be from here up to where you have this line. And in that case, that would have given you, you know, from here to here, okay, it's 270. So this time, right, to be 270 plus your theta. That would be your bearing. So now you know how to find the bearing in the respective quadrants. Okay, so take notes. Is my point well made?
Yes, please.
Okay, so at this point, okay, we are going to have our break. Okay, when you come back, I think this will be yours to try. It's similar to what we just did. Okay, it's very similar to what we just did. So this will be yours. Okay, 3 forces. So here you have to label the forces. Maybe let's, okay, F sub 1 be equal to this F sub 2, F sub 3. So it will make your work very easy in terms of presentation. Then you underline the salient parts. Okay, so, okay, please, okay, let's hold on. Okay, let me see, 5 minutes. Okay, break. When you come back, then we continue. Okay, we've gone now beyond our usual 1 hour. Okay, so welcome back from the water break. Okay, now we know that anytime you are asked to find the resultant, okay, of what vectors, okay, you know that you are supposed to sum all the vectors acting on the particle, okay, on the body, all the forces, you put them together by adding. Okay, so let's look at another situation. Here we have two forces, F sub 1, given in the Cartesian form. Okay, in fact, what I have here, okay, is not well, okay, typed. The I and J should be bold. The I and J should be bold. So it was an omission from my side. So take note. I can correct that. It's in print. So even if I do this, I'm not correcting that. So assuming maybe it's in, okay, writing. So it will be so that when you are writing it, find the third force that will keep the particle in equilibrium. Okay, so I'm going to give you another information, and I think this time around I will ask because we have, okay, science students among us, so they can tell us what we are supposed to do in that situation, what condition we are supposed to use. So quickly we write solution, then we extract. So giving F sub 1, okay, 3i, so that don't forget minus 4j, so that they will be in bold. So you write it and indicate that with a tilde. Then F sub 2 will be equal to minus 14, okay, I, so that, then minus 3j, so that. So that's what we have. Okay, please, the science students, okay, at equilibrium, what can we say about the forces acting on the particle or on the body? Make your physics teachers proud. And what can we say? Okay, so yes, there is no motion. Okay, so when there is no motion, okay, what exactly does that mean?
Please, the forces acting on the body is equal to 0.
Yes, so the resultant must give you 0. That's the meaning. Meaning that the sum of the forces, okay, should give you was 0. So at equilibrium, take note, so that's the only information that I'm adding here. So at equilibrium, okay, your resultant must be equal to 0. Okay, so this implies that here we said a third force that will keep it in equilibrium. So you have three forces, F sub 1 plus F sub 2 plus F sub 3 should be equal to 0. And the 0 that you have here, okay, it's a 0 vector. Okay, so the 0 vector, if your vectors that you are dealing with, okay, are column vectors, then it means it will be the 0 column vector. Okay, if the vectors that you are dealing with are, okay, the Cartesian, then it will be the 0 Cartesian, which will give you 0i, okay, then 0j. Is that clear? Okay, but here, you thank God. The forces that you are giving, they are the friendly forces. I'm talking about the nature of the vectors in the forces. Okay, you can see they are in the Cartesian form. So once they are in the Cartesian form, you can add directly. You thank God. It's only magnitude bearing that you can add directly. So in this case, okay, we can say that this implies that, okay, so I'm going to get my F1, which is 3i, okay, minus 4j tilde, okay, plus F2, which will give me minus 14i tilde, minus 3j tilde, plus what? Your F3 should be equal to 0. So now you add these two and you move it to the other side. So on that note, we are going to get this plus this will give us minus what? 11i tilde, then this the j's. If you, this j and this j will give us minus 7j tilde, then plus your F3 should be equal to 0. So it means your F3 will be equal to, you move these two to the other side. So 11i tilde plus 7j tilde. All correct. Is my point well made?
Yes. Yeah.
Okay, very good. And here, this is how far you can go. Remember, I told you, okay, the nature of the forces in play will tell you the nature of any force that you are asked to find. So because this is in the Cartesian, your F3 must also be left in the Cartesian form. So here, I've not drawn my conclusion. I can put my therefore there, as simple as that. So if you had magnitude bearing forces, then it means, okay, you know, it will be the forces change to the column form. Okay, so your F3 will also now be in the column form, but you cannot conclude in the column form because F3 must also come in the magnitude bearing. So you now change the column to magnitude bearing, that's all. You find the magnitude of that column vector, then the bearing of that column vector, and that will be your F sub 3. Is my point well made?
Yes,
Okay,
please.
so that ushers us into this particular one. Okay, so this is it. You take notes. So, okay, in this case, I think this one too, but you can try. Okay, I will ask you to try this one and maybe we'll discuss it. 5 forces, a lot of forces. Okay, but some of the forces or 2 of them, you don't know the magnitude. Okay, but you are told that they are in equilibrium. And please, he said calculate correct to 2 decimal places, the magnitudes of P and Q. So the magnitude P and Q. So you are finding the values of P and the values of, the values of P and Q. The value of P here and the value of Q, okay, here. But because they will be in equilibrium, please, if you sum, your result must be equated to a column vector. Okay, 0, 0. Then what? You know what you are supposed to do. The sum of all the forces here should be. So you get 2 equations, okay, to solve for P and N. You can try. Okay, so let me see. Let me look at the time and see if you can. Okay, so I think, okay, we should be okay with that explanation. Please, should we start or the explanation is okay? Should we attempt?
Yes, please.
Okay, so this is what I will be very, okay, so in this case, it will be your F1, you know, okay, at you state solution. Okay, solution. Okay, you extract, so 10. You extract all that you are given. Okay, then after that, you know at equilibrium, but you can come and write, but, okay, your resultant, so F1 plus F2 plus F3 plus F4, okay, plus F5, okay, should be equal to 0. Okay, equilibrium indirectly may be at rest. Is my point well made?
Yes, please.
So now you come and find this. So which will be, I'm going to write, this one will give me P, okay, sine 30 degrees. P cos 30 degrees. Okay, don't forget your degrees. Then the other one too, you come and do it. Okay, do that up to 5 times. Which one it contains? The 4th one contains, okay, so the Q. So that will give you Q, okay, sine, okay, 150 degrees. Q cos 150 degrees. I hope you are following. Then plus the last one. Okay, apart from these 2, all the rest you get. So it means here, this will be a value. Assuming, I'm just assuming, this gave us 2. So you get 2P here. Okay, then maybe 3, sorry, let me use 3Q. Okay, I'm just, sorry, 3P. There should be P here. I'm just assuming. Okay, that's the value. I hope you get my point. But you use your calculator to find sine 30. Whatever that you have, you attach P to it. Cos 30, you attach P to it. Is that clear?
Yes, please.
Okay, then plus this will give you, as for this one, all of this one will give you a particular value with no letter. So let me assume maybe this is 6, this is 7. I'm just assuming. Then plus this will give us maybe 8 minus 2. I'm just assuming. This one will also be in terms of Q. So I'm going to get maybe Q. Okay, assuming sine 150 gave me 1, so I will get Q. And cos 50 gave me 2, so plus 2Q here. Then plus, okay, what do I have here? I'm going to get what? Assuming I had negative 2, 5. Okay, so remember we said this must be equal to 0. Must be equal to 0. Is my point well made?
Mr. Hackman,
Yes, please.
So if we are getting said to, should we keep it in the static form?
Yeah, keep it in the
Or
said form. Because
okay.
when you form your equation, okay, you will deal with the said later.
Okay.
Okay, so my point is because you have two unknowns, you are going to generate two equations. The first equation will come from equating the S components. Okay, then you maintain the variable terms on one side or the terms with the letters on one side and take the terms, okay, without letters to the other side. So it means indirectly, this would have given me 2p plus s plus 8, okay, plus q minus 2 is equal to 0. That would be the first one, but I know I will keep. So this implies that 2p plus what? Where is my q? My q is missing. Oh, okay, it's here. Okay, so plus q. Okay, then I will add the whole of this and move it to the other side. So this will give me, what do you call it? 14 minus 2. So I'm going to get 12, but I'll move it. So that will give me minus 12. So that forms my first equation. Then I come in and form my second equation from the second, for the y component. So 3p plus 7 minus 2 plus 2q, okay, plus 5 is equal to 0. Then you know what to do. Collect, okay, the terms in p and q, okay, on one side, then the other terms on the other side. Then you solve the two equations simultaneously for p and q. You are done. Is that clear? So
Yes,
just
please,
try
but
it in our, come again.
please do you use your own values?
Do you use what? Your own values, as in?
No, did you use your own
Yeah, I
values?
use my own values because if I ask you to give me your calculator values, okay, it takes you a while. I still want to make my point. So I use my own values. Okay, I
Yes,
said
please.
assuming, okay, this gave us, sin 30 gave us 2, so this would be 2p. Cos 30 gave us what, 3, so 3p, assuming. So I use my own values. So you will use the actual values once my point is well made. All correct?
Yes, please.
Okay, very good. Okay, so now, okay, at this point, I think we can bring, okay, the curtains down. So this, in actual fact, will be your assignment. Okay, I think, yes. Okay, these two, let me see if you can try, okay, with this and this. Okay, I will capture it and send it to you. Okay, this one and this one. Okay, you try, God willing, tomorrow we'll look at it and solve more complex questions that are not direct at all. Okay, any questions before I finally bring the curtains down? Hello, any questions? Okay, so we are all fine. All right, we thank God. So take note of all the advice and instruction that you've been given in terms of what, dealing with what vectors question. So let me see. Where is the first question? Okay, so let me capture your first assignment. Okay, so on that note, okay, thank you very much. Okay, enjoy the rest of your day. Oops, okay. It's not, I hope you will see it. Okay, I will send it to you because I have light up where I am, the place is dark. So I'm not able to get a clearer, okay, picture. So I will send it to you, okay, later. Okay, so thank you very much. Okay, so bye-bye.